In this video, we're going to look at topic 90, example 4, add and subtract radical expressions. So we are asked, what is the sum of the square root of 20 minus the cube root of 16 plus the cube root of 250 minus the square root of 5? So we need to look for is like radicals. And like radicals have the same index and the same radicand. Right. So like radicals can be added or subtracted, but to do that, they have to have the same index and they have to have the same radicand. Now, if I look at this problem here, none of them have the same radicand, right? 20, 16, 250, and 5. Those are all different numbers. So the index, however, here I have a 2, and here I have a 2, so those are similar. And then I have index of 3, which is similar. So that tells me I should be able to put those together in some form. I just have to figure out how. The square root of 20, we want to look at our perfect squares. So we have things like 4, 9, 16, 25, I'll keep going, 36, 49, and so on. I'll throw in 64 there too. So the square root of 20, what I can do is the square root of 20 is divisible by the square root of 4. So take your square root of 20 and we're going to break that up into 4 times 5. That 4 times 5 can then be reduced. We can take the square root of 4, which is 2, and then the square root of 5 stays on the inside. Now notice that that matches up with that one in terms of the index and the radicand. So eventually we'll be able to put those together. But first we need to reduce or simplify each of these radicals to try to create like terms. The cube root of 16, my perfect cube roots, I have the cube root of 8, the cube root of 27, cube root of 64, cube root of 125, and we'll stop the list there. So 16 is divisible by 8. So I'm going to change that to the cube root of 8 times 2. And then the cube root of 8 is 2, and the cube root of 2 would stay the same. The cube root of 250, 250 is divisible by 125, which is a perfect cube root, and it would be 125 times 2. The cube root of 125 is 5, and that leaves me with the cube root of 2 on the inside. Now, the square root of 5 I cannot do anything with, but I'm going to put a 1 out there in front as a reminder that there is a coefficient there, okay, or a constant. So, real quick, remember this 4 became that 2, this 8 came outside as that 2, the 125 became the 5. Okay. Now, from here, we look for the like radicals, so same index, same radicand. 2 radical 5 is the same as negative 1 radical 5, same index, same radicand. So we do the 2 minus 1, we get 1. The radical stays the same, so we're going to leave it as radical 5. And then my two middle terms are both cube roots of 2, so same same radicand and same index. So I have negative 2 plus 5, which would be a positive 3, and then we're going to keep the radical, the cube root of 2. And that's our solution. All right, so adding and subtracting radical expressions is not all that bad. You just have to make sure that you're only combining terms that are like terms, and they have to have the same index and the same radicand. You'll have to simplify a lot of radicals to get to that point, but once you do it, you'll get used to it pretty quickly, and you should not have much trouble. Remember the simplifying part you've done before, it's just now we're adding and subtracting radical expressions.